In this video, I'm now going to look at what happens once the lift is at the top of the building and wants to come down. And the same effect can happen again. If you hold in your mind what happens if you get in a lift on the top floor and you move downwards, your initial feeling in your body is that of weightlessness. So we'd be expecting that mg minus ma effect. Then obviously the motor then moves the lift, accelerates it, then it starts to move at constant speed and you feel nothing as if the lift isn't moving. That would be the T equals mg effect in theory. And then as the lift starts to decelerate, you get that feeling of weight and something bearing down on you, which would be the mg plus ma. And the only way to show that, again, is by proving it via F equals ma. So if we start at the top of the building with situation 1, we're going to apply F equals ma in the direction of motion, which is now downwards. So applying that, we would get mg minus t is equal to ma. Rearranging, we get t is equal to mg minus ma as expected. That feeling of lightness when you suddenly start to accelerate downwards in the lift. Then obviously the lift is still moving downwards, but this time it's moving at constant speed. It's accelerated to its top speed, and now it's just moving at constant speed. So therefore we have mg minus t again is equal to 0, because obviously there's no acceleration because it's a constant speed. So t is equal to mg. So you don't feel anything, and that would be the same as if the lift was stood still at the beginning of its motion. So that's situation 2. Situation 3 is when the lift starts to decelerate. So as you're coming down, you suddenly start to decelerate. You get that feeling of weight. So if we apply F equals ma now, still downwards because the lift is still moving downwards. Note the acceleration is now upwards because it's decelerating. I could do a downwards arrow with a negative a, but I just like the idea of showing what the acceleration is doing. We get mg minus t is equal to minus ma. So t is equal to mg plus ma. So again, the situation works no matter which way the lift is moving, as long as you apply F equals ma directly and your accelerations are listed as they should be.